Welcome to lesson 3.5, Write and Graph Equations of Lines. So the nice thing is that in Algebra 1, we've already looked at the idea of standard form and slope-intercept form for lines. This lesson, we're mainly going to do a refresher on those of how we write and then how we graph those equations of lines. So the first thing that we want to remember is slope-intercept form of a line. So y equals m times x plus b. M is always the slope. So wherever m is, m times x, m will always be the slope of your line. B, positive or negative, is your y-intercept. So the slope is always m. The y-intercept is always b. So the way that we can take a graph and write an equation is by first finding the slope and second finding the y-intercept before the third step is writing the final equation, y equals mx plus b. So to find the slope, we've already done this in our last few lessons. We're doing change in y over change in x. So if I look at my first example A here, I point 2, 3 and 0, 1. So change in y, 3 minus negative 1 on top. Change in x on bottom, 2 minus 0. That gives me 4 over 2, which simplifies to 2 over 1. So now I know the slope of this line is 2 over 1 or 2. Then I need to figure out what is the y-intercept or the letter b. So I'm going to take one of my two coordinates, either the 2, 3 or 0, negative 1, and we're going to plug those back in once we write the equation with our new slope. So now I have y equals 2x plus b. All I did was replace m with what I know, 2. Then I'm using the point 2, 3 to solve for b. So I'm plugging the 2 in for x, the 3 in for y. So it becomes 3 equals 2 times 2 plus b. 3 equals 4 plus b. Subtract 4 from each side, and b is a negative 1. Now I have all the info I need to write slope-intercept form. So my slope is 2, my y-intercept's negative 1. So y equals 2 times x minus 1. It's a minus 1 because the b is a negative 1. We could also write that as plus negative 1. So in example 2, or part b, we have the coordinates negative 2, 4, 2, 2. So again, I'm going to start with finding my slope. So I did 4 minus 2, and then the negative 2 minus 2. That gives me 2 over negative 4, which simplifies to a negative 1/2. Now I'm going to rewrite my equation, y equals mx plus b, with my new slope. So y equals a negative 1/2 x plus b. Now I can choose either point to plug in for x and y. So I'm using the 2, 2, and I'm going to replace x and y with their proper values. So it becomes 2 equals a negative 1/2 times 2 plus b. 2 equals a negative 1 plus b, so add the 1 to each side, and b equals 3. So my slope's a negative 1/2, y-intercept's 3, so y equals a negative 1/2 x plus 3. And lastly, in part C, we have 2 points, negative 3, 0, and 0, 2. So start with finding the slope. 2 minus 0 over 0 minus negative 3 gives us a slope of 2/3. Set up our equation, y equals 2/3 x plus b. Select one of your two coordinates to plug in for x and y. So I'm using the negative 3, 0. So it becomes 0 equals 2/3 times negative 3 plus b. 0 equals a negative 2 plus b, so add the 2, and b would equal 2. So then I have a slope of 2/3, y-intercept of 2, so my equation is y equals 2/3 x plus 2. So if you have a graph with 2 points, you find the slope, then you find the y-intercept, and then you write your final equation. Example 2 is a similar concept, except now they're giving us a point that the line passes through and the slope. They want us to write the equation. So the first thing I'm going to do is just write y equals mx plus b with the slope in there. So if my point's 2, 4, slope of 1/2, y equals 1/2 x plus b. Then just like the previous ones, we're going to take the x and y values that they give us to solve for b. So I'm going to plug the 2 in for x and the 4 in for y. 4 equals 1/2 of 2 plus b. So 4 equals 1 plus b, subtract the 1, and b equals 3. So then I can write my final equation, now that I know b is 3, y would equal 1/2 x plus 3. So in b, we have the point 3, 0, slope of 2. So y equals 2x plus b. We're going to plug in the 3 and 0 for x and y. So 0 equals 2 times 3 plus b. So 0 equals 6 plus b, meaning b equals a -6. So then my equation for that line, slope of 2, so y equals 2x minus 6 for the -6. And then in C, our slope's a -2/3, so y equals -2/3 x plus b. Plug in the coordinates, and we get b equals 3. So then our final equation, y equals -2/3 times x plus 3. So in this set, it's actually easier than it is with the graph. One less thing to worry about. Now in example 3. Now we're using that idea of parallel or perpendicular lines to find our equations. So in this case, in part A, they told us a line going through 1, 3, and it's parallel to y equals 2x minus 2. So if it's parallel, I know they have the same slope, so I'm going to use 2 for my slope. Then I'm going to plug in the 1 and 3 to find out what b should be. So y equals 2x plus b. So we're just setting it up without the y-intercept. Then plug in the x and y that we know. So 3 equals 2 times 1 plus b. 3 equals 2 plus b. Subtract 2 and b equals 1. So then I know my parallel line has a slope of 2 and a y-intercept of 1 that goes through this point. So y would equal 2x plus 1. If it's perpendicular, I know the slopes need to multiply to be a -1. So if it's perpendicular and my original line has a slope of a -1/3, I need to figure out what times -1/3 equals a -1. So -1 divided by a -1/3 gives me a +3. So my slope of my perpendicular line is 3 or 3/1. Once I figured out that slope, I set up y equals mx plus b with that slope. So y equals 3x plus b. And I'm going to plug in the points, or x and y, from p. So -2 equals 3 times 3 plus b. -2 equals 9 plus b. Subtract 9, and b is a -11. So then I'm going to use my inverse slope here, the 3/1, and the -11 for b for my new equation. So the perpendicular line's equation is y equals 3x minus 11. And then we get into standard form. Now, quite honestly, I use slope-intercept form a lot more than standard form. But standard form can be very helpful just for doing quick graphs and lines. So that's what we're going to look at mainly here. So standard form is a times x plus b times y equals c. The x-intercept is the point where the line crosses the x-axis. So in a graph, we have our y-axis here, x-axis here. So the x-intercept is where we cross the x-axis. And we know how to find that because it's when y equals 0. So if we're in standard form to figure out the x-axis, you just plug a 0 in for y. Now to find the y-intercept, for the y-intercept, it's the point where the line crosses the y-axis, so where we're crossing our vertical axis. And that occurs when x equals 0. So to find the y-axis, when we're in standard form, we just plug a 0 in for x. So graph each equation by finding the x and y intercepts. So to find the x-intercept, we're just going to put a 0 in for y. So it'd be 3x plus 4 times 0 equals 12. So 3x equals 12, divide by 3, and x equals 4. So I know I'm crossing my x-intercept here at 4, 0, or at 4. Then the y-intercept, I'm plugging a 0 in for x. So 3 times 0 plus 4y equals 12. So 4y equals 12, divide by 4, and y equals 3. So in this case, I'm crossing the y-axis at a positive 3. So I put a point at 3. Connect your point at 4 on the x-axis to the point on the y-axis, and you have your line. So once you know where you're crossing, what your two intercepts are, you simply connect them. So in B, we have 2x minus 3y equals 6. To find the x-axis, plug a 0 in for y. So we'd end up with 2x equals 6. Therefore, x equals 3. So I'm putting my dot at the x-axis, or along the x-axis at 3. Then for y, I'm plugging in a 0 for x. So 2 times 0 minus 3 times y equals 6. Negative 3y equals 6. Divide by the negative 3, and y equals a negative 2. So my y-intercept is down here at a negative 2. Connect that point from negative 2 to the point here at 3, and we have our line. And then we have our two special occurrences of a vertical or horizontal line. If we ever have x equals a value, you get a vertical line through that value. So if there's nothing else in the equation, just x equals a value, we get a vertical line through that value. If y equals a value, we get a horizontal line through that value. So as you work through these lessons, be very careful between standard form and slope-intercept form. Realize with slope-intercept form, it allows you to go into more detail and depth with writing more complex or more accurate equations. With standard form, we're mainly just going to use the x and y intercepts to do a quick graph of our line.